Hi everyone, it's Coach Red here, up for another episode of Gee, I'm a Tree. Just kidding. Okay, so first I want you to, in your note packet, you should be on, I think it's about page 5. I wanted you to do the algebraic ratios all the way through to 2x minus 6y all over negative 6y. I want you to simplify them. All right, but we're going to start today talking about the difference. We were working in class on talking about the difference or what a ratio was. And let's just remember that a ratio is a comparison of two or more numbers, okay? All right, so and we could write it as 2 to 3, we could write it as 2 over 3. And remember when we're talking about ratios that we can have a part-to-part relationship. We can also have a part-to-whole relationship. Now, there's other relationships, but those are the ones that we've been working with a lot. Now, a proportion is two equal ratios. So a ratio is an expression. Now, remember, we said that 2/3 and 4/6 were equal ratios. They might not look the same, but when you simplify them, they are the same, okay? We also said that a slope was a ratio, so we will always want to remember that slope is a ratio. All right, but now we're going to be working with proportions, so they are two equal ratios. So once we add that equal sign, what happens? We've made an equation, and so there may be opportunities for us to use a proportion and ratios to solve equations. And I know I'm getting a little messy here, but I'm sure you'll work with me. All right, so let's talk about how we can write ratios. There's lots of ways that we can write ratios, but here's an example of a ratio that's an equation. I have A over B equals C over D. Now, that same ratio could be written as A colon B equals C colon D. Remember using the colon symbol. These are equivalent forms of the same proportion. Because they have an equal, they are proportions. Now, I want to look at this one in particular. So there are the first and last terms. So this term and this term. Let me get that arrow out of the way now. Those are called the extremes of the proportion. Okay? And the middle terms are called the means. Okay? So here we go. Here are our extremes, and here are our means. So what's really interesting is that the product of the means equals the product of the extremes. So you've learned about that in the past. Most teachers in middle school like to tell you that that's basically cross multiplication, but I don't really like to use that because that doesn't work in every single case with equations. So it's called the cross products rule, and it is a definition. When we use these two definitions, extremes and means, the product of the means equals the product of the extremes. That means that A times D equals C times B. Now, if you feel quite comfortable with it, I'm totally okay with you doing that. So let's look at other ways we can write proportions so that you can also make it easier, okay? So A over B equals C over D actually could be written many different ways. We could write it as B over A equals D over C. All I did was flip them both. If you flip them both, then they are equivalent proportions. I also could do A over C equals B over D. Okay, what did I do? I put the tops on as a fraction and the bottoms as a fraction. That is another way to write these. And if I use the cross products rule, the means and the extremes, look, AD equals BC for all of these, okay? All right, now I could also, at this point then I could write A over B. Oh, I did that one already. I could actually do A plus B over B equals C plus D over D. So I'm basically adding the denominator to the top on each side, and that's going to actually give me an equivalent proportion. Okay? All right, let's also know that we could write it as AD equals BC. Okay? All right, let's try that. Let's try that. So if x over y equals 5 over 2, then what are some other ways? How can we rewrite the proportions using the properties? I'd like you to try it 4 different ways. Press pause and then come back to me, okay? All right, so if you did that, I did y over x equals 2 over 5. I did x over 5 equals y over 2. I could do that. I love that property because sometimes that helps me simplify things. I could do, let's see, 2 times x equals 5 times y. Or I could do x plus y over y equals 5 plus 2 over 2, which is 7 over 2. Now, this one I tend to use only with geometric figures, and I'm going to talk about that a little bit later in class, okay? And we'll talk about why that one's helpful. All right, so if you could complete the statements and bring those to class, we'll go over those in class. All right, moving on. Let's look at how we can use the properties to solve. Now, the most important thing when you go to solve a proportion is to see if you can simplify up and down first, but not diagonally. You cannot simplify diagonally. So before I even start the proportion, before I even try to solve using any method, I'm going to try and simplify. So 7 over 14 simplifies to 1/2. So now I have x over 4 equals 1/2. Now, some of you might jump to cross multiply. Some of you might jump to clear fractions. But Coach Fred really wants you to think. Proportions are 2 equal ratios. So if you think about this, 2 times 2 gives me 4. So that's that ratio multiplier. So remember that ratio multiplier, whatever you do to the denominator, you have to do to the numerator. So I'd have to multiply 1 by 2, and so that means x is equal to 2. You might have just seen it. If you're Teddy, you just saw it. So let's think about that. That's important. We do want you to use your reasoning skills. All right, let's look at this next one. Again, we want to simplify first. I can simplify 6 over 3. That gives me x plus 4 over 4 equals 2 over 1. All right, now another way to solve a proportion would be to clear fractions. The lowest common denominator is 4, so I'm going to multiply both sides by the lowest common denominator. I'm going to clear fractions. This is the way I tend to solve most proportions after I simplify them because they're just much easier this way. So the 4's will cancel and I'll be left with x plus 4 equals 8, and then I subtract 4. The reason I like this over cross multiply is because you sometimes get confused with this term I've heard kids use before, cross cancel. There's no such thing as cross cancel. And you don't really know what you're doing. It's just a process. But clearing fractions, we know that it's helping us simplify by multiplying a number to both sides. We're using a property of algebra. All right, let's look at this one. This is where it gets a little bit trickier, okay? So now we look at the proportion. We have a proportion because we have 2 equal ratios. And we can't simplify 3/2. It's in its lowest form. So our LCD is 2 times 2x plus 1. So we multiply both sides of the equation by 2 times 2x plus 1 and 2 times 2x plus 1. All right, so the 2x plus 1's cancel here, and I get 2 times 4x minus 1 equals the 2's cancel here, and I get 3 times 2x plus 1. Okay, and then I solve. So now I have to distribute, which gives me 8x minus 2 equals 6x plus 3. All right, if you go on and solve that, minus 6x. I'm going to add 2 to both sides using the addition property. So 2x equals 5 and x equals 5 over 2. Now remember, we're going to always leave our answers as fractions because decimals don't exist in algebra. All right, now 4 is interesting, and I want to spend a second talking about this, and I'm going to stop after this one. 4 is interesting because, do you see that 4 and that 2? I actually can use one of the properties to simplify this a little bit. I can actually do a couple of things, okay? I can write this as 4 over 2 equals 2x plus 8 over 3x. So this is one way I could do it. And then I'd be able to simplify the 2 and the 1. It makes it much easier. Then, when I clear fractions, I multiply both sides by my LCD, which is 3x. Super easy now. 3x times 2 gives me 6x. 3x's cancel, and I'm left with 2x plus 8. All right, now I just subtract 2x, and I get 4x equals 8, and I divide by 4, so x equals 2. Now remember, what does x equals 2 mean? It means that when I plug 2 in for x into this equation, it will make the equation true. It will make the equation true. Okay, now there is actually one other way I could do this problem, so I'm actually going to erase this. I'd like you to see this. I happen to notice that the top had a common factor of 2, so I could pull that out, and I'd be left with 2x plus 4 on the top. Make no changes other than that. I love that math you can do it two different ways. All right, so then this would simplify with the 4, and what you might notice now is that I have a 2 in the denominator of both my ratios. That means the tops have to be equal to each other. So x plus 4 equals 3x, and I subtract x. And so 4 equals 2x, and x equals 2. Isn't it great how math you can do it multiple ways? So I want you to really take a second and pay attention when you're solving proportions, okay? All right, guys, hopefully that video was helpful. We're going to be practicing harder proportions tomorrow, so get ready. See you tomorrow.